Suppose you are given this problem, this circuit diagram, and you are asked to find the total resistance of this network. What will you do? The first thing you need to do is to identify the type of circuit you are dealing with. This very particular circuit is a parallel circuit, because both resistive elements have the same 2 points in common. So to find the total resistance of this network from this circuit diagram, resistor R1 is 15 ohms, resistor R3 is 15 ohms, and resistor R5 is 15 ohms. Since these resistors have the same resistance level, let us group them together. And also resistor R2 and resistor R4, they are 3 ohms and 6 ohms respectively. Let us group the two of them also together. So we have a new circuit diagram which will be in this form. The circuit diagram will be in this form. We have a new circuit diagram in this form, where here we have another resistor connected in parallel to this. We have another resistor also. One, two, three, four, and the last resistor will be connected here. Okay, so here will be what? 15 ohms. Here will be 15 ohms. And here will be what? 15 ohms. Here will be 3 ohms. Here will be what? 6 ohms. So this resistor here, which is 15 ohms, is resistor R1. And the second resistor is resistor R3. And the third resistor is resistor R5, which is 15 ohms. Resistor R5. And the 3 ohm resistor is resistor R2. And the 6 ohm resistor is resistor R4. Resistor R4. Okay, now we have grouped the same value of resistors together. So we can call this, we can make this RT prime, and we can group these two as what? RT prime. Remember, it is the total resistance, which is RT, we are looking for. And RT, so from here, the 15 ohm resistor, they are the same values of what? Resistors. Whenever you have the same values of resistors in what? Parallel, don't use this formula, which is 1 over RT, which is equals to 1 over what? R1 plus 1 over R2 plus 1 over R3. Don't use this formula. Whenever you have the same values of resistors in parallel, don't use the formula. Okay, I will show you what to use. In this network, since the resistance values are the same, remember it is resistor what? RT prime. So the total resistance in this group will be what? Pick one of the resistance value, which is 15 ohms, and divide it by the number of resistors. The number of resistors here is 1, 2, 3, is 3. And 15 divided by 3 is what? 5 ohms. So that is the total resistance in this very particular group. Okay, in this group, which is 3 ohms and 4 ohms, the total resistance, which is RT prime, will be what? This times this, which is R2 multiplied by what? R4, all over R2 plus what? R4. So that RT prime will now equal to what? 3 times 6. 3 times 6 divided by 3 plus 6, which is 3 times 6 is 18, divided by what? 3 plus 6 is what? Is 9. So it will be what? 9, which 8 divided by 9 is 2 ohms. So at this point, we are plotting the total resistance in this group, and we are plotting the total resistance in this group. So now we will have our new circuit diagram in this form. We will now have our new circuit diagram in this form. Which is here will be what? This group was arrow T plan, which is arrow T plan, and this group was arrow T plan. Remember, we are dealing with total resistance, which is arrow T. So now we still have these resistors in what? Parallel. So what are we going to do now? We will now know that the total resistance of the circuit, we will now have the total resistance of the circuit will be what? Arrow T plan all over arrow T plan plus arrow T what? Plan. So now let us substitute the value of what? This resistive element into this word equation, which is 5 and 2. So arrow T plan is what? 5 ohms multiplied by arrow T plan is what? 2 ohms divided by 5 plus 2. So 5 times 2 is 10, and 5 plus 2 is 7. So arrow T, which is the total resistance of the network, will now be what? 10 divided by 7. For my calculator, 10 divided by 7, it will give us 1.43 ohms. 1.43 watts. So this is the total resistance of the what? Network. So this is our final answer. We were asked to find what? Arrow total, which is the total resistance of this network. Remember, parallel elements can be interchanged without changing the total resistance or the input word current. That was why we interchange this word element. Normally this word is question, but we interchange it because this element, this resistive element, the values were what? The same. So we group them as one, and we group these two values, which was different, as one. So in a parallel circuit, parallel elements can be interchanged without changing the total resistance or input current. So this is the end of the video. If this video is helpful, hit the like button and subscribe for more electrical circuit theory calculation. See you in my next video. Bye.